You're now listening to the Deep Edge Podcast with your host, technology expert Ray Moda, giving you the rundown on telecom, cloud, and all things business and tech. This is the Deep Edge Podcast. Let's go!
Hello and welcome to another edition of the Deep Edge Podcast. I'm actually excited about this particular topic because it's something that there seems to be a little bit confusion, whether it's mobile access edge computing or multi-access edge computing. So joining us today is an expert, Dr. Peter Fetterolf, who actually joined us before. And we're going to break down the discussion into why we need it, right? Which I think is always an important question, what it is and what are the architectural considerations. And more importantly, it's what are the business cases that drive this and the business value. And then lastly, we'll get into some of the application and some of the use cases that people could consider. So Peter, thanks for joining the podcast again.
Yeah, thanks a lot for having me, Ray.
Yeah, Peter, do you mind going in and addressing some of those pieces? Because I think there's to be some confusion in the market about what it is.
Sure. So let's just start out with MEC, MEC. Okay, what is it? Okay, so the acronym, it's multi-access edge computing. Originally, it was mobile edge computing, and then it was changed to make it more general. But the key thing is, it's really edge computing with a focus on service provider, telco networks. Okay, so next thing is, why do I need to put applications at the edge, right? So it's really primarily two reasons. One is latency sensitive applications. So these are applications that have to have very low latency and also have requirements on jitter, okay? So that's number one. Number two are applications with very high bandwidth requirements, okay? And in these cases, the reason you want to put those applications at the edge of the network is to essentially reduce the bandwidth going through the network. So this is essentially things that people have been doing this for years with CDN networks. Okay, and so what's really different now is these applications are really moving farther out to the edge. Okay, and if the applications don't have one of those two requirements, latency or bandwidth, then you're probably better off in more centralized regional data centers or national data centers.
Yeah, no, that's great there. Yeah. I mean, do you mind going further into, because I mean, I think, with MEC, right, there's a lot of confusion, and you just mentioned it, is what is the real motivator, right? So it seems like latency type applications, what would you say, IoT and things like that are very sensitive.
Yeah, and so Ray, I'm going to get into like what some of those key applications and the key use cases are.
Okay.
Like, first of all, let's say what is MEC? So one thing is it is being standardized by it, and it's an architecture, that's being driven by telcos and vendors. Okay, and then the most important thing is it's aligned with NFV and most specifically cloud native architectures. And we'll talk a little bit more about the architecture side. So then next question is, where are these edge nodes, right? When we say edge, what do we mean? It can mean a lot of different things. So it could be what we might call the very far edge, which would be actually in cell sites or radio sites. However, more typically, these might be in, say, access COs, central offices, that are connected to, say, 20 to 40 to 50 different cell sites. And then also you have aggregation central offices, which would be more in metro areas. You might have several aggregation central offices. And then you could even have regional offices. So the edge can kind of move, from more regional to aggregation out to access and even out to the very end, depending on what the applications or the use cases are.
Yeah, what I was going to ask Peter is on that question there, no, because it makes a lot of sense. Good, you're talking about it there. Is there a play and where does the telco fit into this particular environment there?
Yeah, so let's just look for a second and say, okay, what are the telco advantages in edge computing and MEC? So if we look at public cloud computing, right, it's really dominated by the big three, AWS, Azure, and Google. It's really difficult. I mean, I think service providers, telcos have tried to get into that space, but it's quite difficult for them to compete. Now, one thing we should note about the current public cloud, it's really based on very large national and regional data centers. Okay. Now with MEC and with edge computing, it's really kind of different, right? Because now we have this distributed model. And this is where the telcos and the service providers come in, because they've over hundreds of years have built out these networks with central offices. So they have a lot of real estate already. They have the network infrastructure. The one thing that they don't really have right now, at least on a wide scale, is those central offices are not really yet converted to data centers. But that process is underway. So as we see this transformation of the central offices to data centers, the telcos and service providers are going to be much better positioned, to be able to serve the edge.
Yeah. No, I think, Peter, one question to go back to that is regarding, because you mentioned there, I see, the cloud operators. You think there'll be somewhat of a partnership going on with them, or what role?
Yeah, so that's a really good question. And actually, we're starting to see that already. So I think clearly, a lot of the telcos and a lot of the service providers, they have this infrastructure, right? They have the network. They're already playing in a lot of these areas. However, they don't really have the real expertise in cloud and in cloud native and all those capabilities. Now, the tier ones and a lot of these guys are building that up, but we are now starting to see some partnerships that are starting to emerge. I mean, just recently, even today, I saw a news flash about Google and Telefonica partnering. I think we're going to see more of that. Now, so let's talk a little bit about the business case. Why do I want to do this? So, if we look at 5G, right? 5G, the telcos are spending billions and billions of dollars building out these 5G networks. But one of the problems is that, we're not seeing ARPU going up. It's not that consumers are going to pay more money for 5G than 4G. They're just going to expect to have 5G. So the current business model, for 5G, at least on the consumer side and even somewhat on the business side, is that, you're going to invest billions and billions of dollars so you can avoid losing customers, right? That's a terrible business model. So clearly, and I think everybody in the industry understands this, is that clearly there's a real need for new services. These are new services that are going to generate new revenue on top of that existing revenue. Because without that, there's essentially really no business case for 5G, and we're going to see big problems with profitability. So that, in my view, that's a must, new services. So there's a lot of areas for new services, and MEC, or mobile edge computing, is certainly one of them. And what I see there is probably number one on the list is business services. So, working with enterprises, IoT and other sorts of things, providing these business services. The other thing is also new consumer services and revenue models with third parties that have been established.
Right. And the mindset, because you mentioned that a lot of these COs need to be converted to somewhat maybe like an agile data center, right? So it's also the mindset, because there's these challenges on spending all this money with 5G, that they want to make sure they optimize their OpEx. I mean, it's automation and orchestration going to be a key role in this transition?
Yeah, for sure. So one of the things, and again, I'll spend a little more time also on the architecture stuff, but I think a key thing is going to be cloud native, right? Orchestration, automation. One of the things we're seeing right now is that, in a lot of the bigger traditional data centers where we have virtualized packet core and virtualized IMS, it's traditionally run on a VM like OpenStack, right? And a lot of these VNFs are running on VMs, that require a VM like OpenStack. As we move to the edge, I'm seeing a lot of the service providers go with a pure cloud native architecture, meaning that they're not running in VMs, they're running in containers, and they're using Kubernetes. And associated with that is orchestration. I think orchestration is a must-have because of the fact that, just to the level of scale that you need to get to, you got to be able to do that.
Now, you're able to talk about present mode of operation moving to what this architecture potentially looks like at all?
Sure. Yeah. So in terms of the new architecture, right? The present mode of operation is, I've got central offices today with basically physical equipment, right? And these things have been around for years and years and years. I have cell sites with primarily physical equipment. So what we're seeing is an overall migration to, transforming central offices to mini data centers. And there's a key part of that is basically the virtualization of a lot of these functions. So some of the key things we're seeing is, number one, the RAN. And we did another podcast a few weeks ago on Open RAN. And with Open RAN or virtual RAN, what's happening is components of the RAN or the radio access network are being virtualized, okay? And so there's components called the CU, which is the central unit, the DU, the distributed unit. And so those pieces will be moved into these edges wherever they are, and they're going to be running on top of this cloud native architecture. Okay, now the other big component that has been virtualized now for some time is the packet core. Okay, however, traditionally the packet core architecture is one in which you have a centralized packet core. Whether it be physical or virtual, it's more central. So within a given region or within a given large metro center, all the traffic would go back to that centralized packet core. So what's happened over the last few years is we have essentially this CUPS architecture, which really allows the separation of the user plane or the data forwarding plane and the control plane. So you can put the control plane in that central location, and then the user plane or the data forwarding plane can move out to the edge. Okay, so now this is really, really critical for MEC or for these edge compute applications, right? Because if I want to put applications at the edge of the network, I better have my packet forwarding at the edge of the network, right? Because otherwise, I've got a mobile user, right, who's sending data traffic from their smartphone or laptop or wherever it's going into a cell site, right? And now it's going all the way back to that central location to the packet core and then coming back out to the edge. Well, that doesn't make any sense at all, right? Because that's defeating the whole purpose of the edge. So the first part, as I see it, of the edge is what we call these telco NFV apps. So things like CUPS, the virtualized forwarding plane, the packet core, moving that out there, and then also the RAN components. So moving that minimum, the CU, the centralized component, has to be in that location because that's the thing that connects to the packet core. Okay, so that's kind of the first step, is building out that infrastructure. And we've shown in our previous podcast that there's a pretty strong business case for Open RAN, as well as we've shown pretty strong business cases for CUPS in terms of moving that traffic out and reducing traffic. So now, okay, that's step number one, right? My NFV telco applications and building that on top in a mini data center, on top of cloud native applications with Kubernetes and orchestration. Now, on top of that, I can start layering various MEC apps, and that's typically going to be done in conjunction with various partners.
Right. Now, I see you brought up the part about use cases earlier, right? And one of the things I wanted is just go over what are the real use cases and also what's really pie in the sky. Like how real are these use cases? How far away on them? And if you could break it down into a few there.
Sure. Yeah, that's a great question, Ray. And that honestly, that's a question that I get asked all the time by my various clients and people in the industry that I've been working with. So like I said, there's the key things are like latency, jitter, and bandwidth. So the way I like to look at it is, let's look at low-hanging fruit to start with. Okay, let's start with something where I know that there's a need and I know that there's a business. Okay, so the one that I like to pick out as a starting point is video CDN. Okay, I mean, we've been doing this for years and years and years, and honestly, Netflix and Amazon and these other video providers, they couldn't provide the service they're providing today without a CDN. So there's essentially nothing new about that. There's also business models that have been established, in terms of the content providers, working with the CDN providers and providing them a revenue stream in order to have, essentially a network that will essentially deliver to their, customers a service that's consumable and usable. Mm-hmm. So what's really different here? Okay, so here basically now, the typical video CDNs are edge, but they're not anywhere near the far edge. Okay, they tend to be, CDN nodes in a metro region. So, I live in Berkeley in San Francisco Bay Area. A CDN node might serve, the whole Bay Area, or maybe say the East Bay and another CDN node serving, the peninsula, something like that, right? Now, as with 5G, right, and with a lot of mobile users and with higher demand for video, and then with moving to 4K and other sorts of things, we've got to move that CDN farther out to the edge. And that's where this comes in, because now some of these edge nodes, they are really much, much closer to the base stations themselves, right, much more closer to the end user. That's going to reduce a lot of traffic inside of the network. It's going to provide much better performance to the end user. So that's one that I look at kind of like low-hanging fruit. It exists today. It's just a matter of moving it farther.
Yeah, I mean, that's a hot area, which, certain service providers can get engaged right away on it because the business value proposition is right there. So that's a really quick short-term one there.
Yeah, and let's look at another one, okay, that I personally kind of like. It's cloud videos, game streaming. So today, of course, video gaming has been very, very popular. It's very difficult to stream these games from the cloud. So typically the games are set up, even if they're multiplayer games, where you have a lot of the graphics and everything locally, either on your smartphone or on your computer or on your connected device. Now, what the gaming companies want to do is they want to move that all to the cloud. So basically, everything is in cloud. The games are being rendered in the cloud, delivered out to the endpoints, whether they be PCs, tablets, or smartphones. There's a lot of benefits to doing that, because basically you can kind of play any game, and also multiplayer games. So what's the problem? The problem is, number one, latency. Mm-hmm. If you're doing multiplayer gaming, you got to have really, really low latency to make that work, because you're shooting people, you're blowing things up. That has to kind of happen in real time. The other big problem is bandwidth, huge amounts of bandwidth required, and it's getting to be more and more bandwidth intensive. So this one is one that's really, really well suited to the edge. And also, I think you can also make the argument that without this kind of edge computing, it's not really practical, just because of the latency and the bandwidth requirements. So that's another one where there's an established marketplace. It's kind of a new app, but we know that there's a lot of customers out there. There's no questions about that.
Yeah.
Okay. So another one, that's also a pretty well, existing kind of application use cases, video surveillance, especially video surveillance with AI and machine learning. Now, this one obviously is, there's a lot of issues around privacy and things like that. But we know, like, places like China are doing this big time with facial recognition and everything else. Whether or not this is a good thing to do or not, or whether or not it can be done everywhere, it's going to be done in different levels. But the key thing is, as you have a lot of these video cameras and surveillance, again, there's a lot of bandwidth required, but also you need to have intelligence. You don't just want to store all this video forever. You want to store video that's interesting and video that's important. A lot of that exists, and it makes a whole lot of sense to do it at the edge of the network, essentially to reduce that bandwidth going out there. Another one, so let's look at a little more forward-looking now applications. So another one, of course, that has gotten, a lot of people are talking about is AR, VR. That's augmented reality and virtual reality. And there are, there's applications out there today, but it's not really wide scale. It's not really being used in a big way. Now, this is an application that could be both, for businesses and or for consumers. And certainly in businesses, guys who are out in the field or working on, repair work, or, be able to put on and see like a whole schematic diagram of, or, underline the plumbing under the street. And you can imagine there's a lot of business focused use cases there, as well as I think on the consumer side, you can extend your gaming experiences and things like that. But anything anything that's business related also is good, because that's where I think really the service providers really need to start generating more more revenue from the businesses. Related to that also is IoT. And so with IoT, clearly that's developed over the years. It's very important for businesses. Today, a lot of IoT is handled, by sort of edge compute using Wi-Fi, say in factories and things like that. But as we have IoT applications that are really going to require 5G, require the mobile network, that's kind of a key place where the edge computing and the IoT gateways are going to make a whole lot of sense there.
All right.
Last one, and there's many apps,
Mm-hmm.
so we could go on and on. But the last one we can't really go with without mentioning the connected cars, right? So connected cars is kind of a big one. The holy grail of connected cars are totally self-driving cars, and there I think there's pretty well consensus that you're going to need a fair amount of edge computing capability just because of latency and bandwidth required to communicate with these cars. But today there's also a lot of applications. Not all of them necessarily require the edge. However, as we get more and more bandwidth, there can be more argument to use the edge. So for example, some of the applications we're seeing today and some of the emerging ones are like infotainment. So, just think of Tesla with, the big screen and, being able to get your podcasts or your music or all that, but also then you have your maps and your navigation and show your battery efficiency and all this. That's why it's called infotainment. There's predictive maintenance, telling you, okay, when is the car going to need maintenance, usage-based insurance, what we call ADAS or advanced driver assistance. Now, I should point out that not all these apps require the edge computing, but we are seeing drivers there in connected cars that are going to be pushing us to the edge in the future.
Yeah, no, this is good because I think you touched on real opportunities that a service provider could prioritize, some short term, right, immediate impact, and some from a longer term point of view there. But as you mentioned, there's more. Now, I see you're going to talk about now is the BAE, the business analytic tool, and how you used it to create models for this.
Yeah, so I think one of the things, Ray, that you said when we started out was that it's all about the business cases at the end of the day, right? I mean, there's all the architecture and the technical side, which I think is very important. Has been but there's a lot of people focusing on that. I think the key thing here, like we said, look, if you're spending billions of dollars on 5G and you're going to spend billions of dollars on the edge, we need to really understand the business case. So we need to understand the revenue models, right? And we need to understand the cost side and what the profitability is. That's number one. But also the other key part of the business models is really understanding where's the low-hanging fruit. So, talked a little bit about some of the applications that are low-hanging fruit, but the other part of low-hanging fruit is where should I do it? And how far out in the edge should I go? And and what's that transition, right? Because like I said, I could be in an aggregation data center that's covering 1,000 cell sites, or it could be an access data center that might connect to 20 or 50 cell sites, or I could actually be in the cell site itself, depending on what the requirements are. So, we have the BAE is what we call a business analytics engine. It's a software modeling and simulation tool, and we have a lot of flexibility to create different models, and we have some also canned use cases that can be used. But this is what we've been doing as we work with our customers to plan and to determine where to go first and what makes sense, what are the revenue models, and what's going to be the relative profitability. Because like I said, I can't emphasize how important that is, especially on making such big bets with these very large number of edge nodes.
Yeah, no, this is great, because I think it's something from a simulation point of view becomes more credible. Now, how do you model and how do you build it there?
Yeah, so the way our BAE modeling system works is essentially it really starts with the whole concept of tenants and endpoints. Okay, and essentially, I can have a multi-tenant system, and this could be actually used when we have cases with network slicing and things like that, or VPNs. The tenants can have endpoints, and endpoints have services associated with them, and then the services map to applications, and those applications run basically in cloud native environments, and they could run in centralized data centers, or they could run in edge data centers. And we have very sophisticated cash flow models that essentially really design the network based on demand, based on users, based on traffic, based on application. And then from that, we can look both at the revenue side and the cost side, and we can do what I call, really the microeconomics, as opposed to just the macro picture where we do an Excel model and we look at the big picture. Here, this is more the micro picture and looking at specific data centers and saying, okay, I've got 1,000 edge sites in these specific locations. I've got this amount of traffic. What is going to be the real demand? What are the real requirements there? What are all those costs, and what kind of revenue can I see? So that's basically how we use the BAE to attack this problem.
Just from a clarification point of view, so it's a cloud-based application, correct?
Yep.
And it pretty much allows you to be able to create simulations and modeling for almost any environment where you can compare present mode of operation, especially as people are moving to this cloud and more virtualized world, correct?
Yep, that's correct.
And from that, right, is there an opportunity for some of our listeners that want to try like a freemium version or something like that? Do you have something like that in place?
Ray. So we have now come out with what we call a freemium version of the BAE. Mm-hmm. So people can try it and see how it works and use. We don't have all the features available on that, but we have a lot of features available. And basically on our website, ACG, if you look for BAE, there's a button. You can just push that, and it'll send off an email to me, and I'll set up an account.
Awesome.
Get them up and running.
Awesome there. Yeah. Okay. So are there any sample outputs that you can review really quickly at all there? Or?
So the outputs are we've got a really, really wide variety of outputs, right? Mm-hmm. So we don't really have time to go through all of them. But what we've done is we've done a lot of visualization mm-hmm. of the economics. And this is one example, and on the podcast, we can't really see it. But basically what we do is, one of the problems we had is if I have differences between scenarios. So I'm looking at, say, a virtual RAM versus a physical RAM, or maybe a CUPS architecture versus centralized architecture. What are the differences in CapEx and OpEx, and how do those differences break down between the different expenses? So we have a very nice kind of dashboard to allow you to see what those differences are, but then to dive deep and see what the nature of the differences are. As well, we have many other visualizations using Sankey charts, mm-hmm. and using tree maps, and using pie charts and other kinds of graphical means, as well as cash flow statements to provide a lot of the detail. Right. So I would say the freemium version is a place where people could start with that, and then we we could help get people up and running if there was interest in providing more of the detailed model.
Yeah, so on top of, tell me if I'm correct, so on top of being able to create these simulations and economic models for a specific use case, you could actually get involved a few ways where you can say, well, here's present mode of operations, here's the OPEX, CAPEX, TCO, or it could even be a revenue-based model where you compare it to future mode of operation. But it sounds like you can also have multiple architectural scenarios, architecture A, architecture B, and simulate what the difference are regarding OPEX and CAPEX and margin and those type of things.
Yeah, that's correct. And relative to MEC, as we're talking about here, one of the key questions is, okay, where, how far to the edge, what regions, right? Okay. Then the next key question is, okay, what applications in what order? And then with those applications, what are the revenue models? Okay, so you can understand those things at a fairly high level, but with the BAE, then we can plug that information in and we can do a simulation and we can compare different use cases in terms of, and compare these things over time, right? As we move from, say, aggregation edge to access edge to maybe even out to the cell site itself at the very far edge.
Awesome. Well, Peter, I'd like to thank you for joining. You did a good job, at least from a high level, explaining MEC, and then hopefully we'll have more that we can go deep into this use case if you don't mind coming back there.
Yeah, sure thing. Thanks a lot, Ray.
Thanks for joining us for this episode of the Deep Edge Podcast. Make sure to follow Ray Moda on Twitter and LinkedIn @RModa. If you enjoyed the podcast, please make sure to subscribe, rate, and leave a review on iTunes. Want even more? Head over to acgcc.com to access exclusive bonus content. Till next time.